So with worksheet 69, we're going to start out with number 3. The moon has a radius of 1,080 miles. For a sphere, that's all we need to know. What is the volume of the moon? Well, my first step in finding the volume of a sphere is to cube my radius, 1080 times 1080 times 1080. I have a feeling we're going to get a fairly large number with this. Good Lord. Okay, what is that? Is that 1 million or 1 billion? That's 1 billion. Yeah, 1,259,712,000. That's our number. All right, now we're going to multiply that by 4. And we get 5,038,000,000. Okay, I'm just going to do times 4. I'm not writing that whole thing out again. 5,038,848,000 is my new number, right? Even though these numbers are abnormal to what we learned like in our notes and on the worksheet, we're doing the same process. That's what this is all about, the procedure, the steps that we take to get our volume. Let's divide that by 3. I hope it comes out even, and it does. 1 billion divided by 3 gives me 1,679,616,000. What's my last step going to be? Step 4. Times it by pi. So in our calculator, we'll do times pi. And we get 5,276,000,000. Let's see, let me do it this way. There we go. 5,276,669,286 what? Miles cubed. Boom. So if the moon were hollow, for example, we could fill the moon up with 5.2 billion cubic miles of material. That's an insanely large amount. And the moon is like a fraction the size of the Earth, so we can only imagine what Earth's volume would be. And that's what we get. It's a weird number, it's a large number. That's our answer. Did anyone get that for number 3? 5.276 billion. Okay, Jackson, Darius, Ayana, Ty, Devin. Okay, great. To the back side we go with number 6. Number 6 is a tricky one. A new container of tennis balls contains 3 tennis balls, each with a radius of 3 centimeters. The container is 18 centimeters tall. So I'm going to label this. Our container is 18 centimeters tall with a diameter of 6 centimeters. So what would my radius be if my diameter is 6? 3. Right? If my diameter is 6, my radius is half of that, which is 3. And we know that the tennis balls also each have a radius of 3. Okay, the question is, what is the volume of air inside the unopened container of tennis balls? So you have to think about this rationally for a second. We've got this whole container, right? That container has some volume. Each of these tennis balls has a volume, and the volume that those tennis balls represent is taking away from the volume of air inside the actual container. So what we're finding with this volume is all of this red space around the balls that represents air inside the container itself. So we'll have to find the volume of the container, the volume of these 3 these 3 spheres combined, and then we're going to subtract. So let's start with the volume of the cylinder. The volume of a cylinder is pi r squared h. Pi r squared h. What's my r for the cylinder? 3. What's my age? 18. Right, it's in the question. 3 times 3 times 18 gives me 162 pi. Or about, if we round that, we get 508.94 cubic centimeters. There's the volume of our cylinder. Now let's find the volume of one of our spheres. It'll be 4 pi r cubed over 3. Well, 3 times 3 times 3 is 27. Times 4 is 108. So 108 pi over 3. 108 divided by 3 is just 36. And 36 pi is what? 113.1 cubic centimeters. Okay. So let me draw this in a way that might make sense. Here's our container, right? I'm going to do the container in blue. This total volume, let's just say, is 508. We've got 3 spheres within that cylinder that are all 113, 113, 113. And we need to solve for all of the air left in the container around those spheres. Hopefully that's a good visualization of what we're doing. So we're going to set up an equation, kind of. 508.94 minus 3 times 113.10. So the total cylinder minus 3 of those tennis balls on the inside. 3 times 113.1 gives me 339.3. 508.94 minus 339.3 is 169.64 cubic centimeters of air. And we can see why this was a challenge problem, because we had to do a couple different things. Think critically, logically. Did anybody actually get this answer for number 6 on their own? 1, 2, 3, 4. Okay, that's to be expected. Hopefully you see what we did there. What questions can I answer about what we did? All right. Fine with me. Yeah, Ross.
How did you get to 162?
Right here. 162. Oh, this one? We just did 3 times 3 times 18. So in our calculator, 3 times 3 times 18 gives me 162. So yeah, that's just the volume of the cylinder. Pi r squared h. R squared h is 162. And then we throw that pi on the end. That's how we got 508. Great question. So it's like a 3-parter. We have the volume of the cylinder. We had the volume of one single sphere. And then we did Iona. Then we did the cylinder minus all 3 of those spheres. Boom, boom, boom. And that gives me the remaining volume in that cylinder. Now, number 7 was also a little bit tricky. Let's think about the information that we have here and see if we can work our way around it. A cylindrical barrel of oil. All right, if we're working with a cylinder, I already know, here's my formula. Has a 1.5 foot radius. Okay, boom. Radius is 1.5. And this barrel holds approximately 28.27 cubic feet of oil. Now, where I saw a lot of people make a mistake on Friday was they put this number as their height. But height is never measured in cubic feet. What quantity do we know always is measured in cubic units? The volume, right? So my volume is 28.27. It says find the height of the barrel. So we don't know what H is. Right? But I know what R is. I know what V is. I'm going to plug in what I know for R and what I know for V. And I get the equation. 28.27 equals pi times 1.5 squared times H. So it's like we're setting up our normal equation, except instead of knowing what H is, we know what V is this time. Now we're going to solve this just like one of our good old equations that we know how to solve. I'm going to work out this right-hand side first. 1.5 squared gives me 2.25 times pi gives me 7.07. 7.07 H equals 28.27. Now if I'm multiplying H by 7.07, what's the opposite of multiplying? Dividing. So we'll divide by 7.07. What I do to one side, I have to do to the other side. What happens to these 7.07s? Cross them out. They cancel. Leaving me with H all by itself. And then let's see. 28.27 divided by 7.07 gives me 3.998585. We're going to round all those decimals up to a clean 4 what? Well, so the 8 bumps the 9 up to a 10, and we clear out all our decimals. This rounds up to a 0.0, 4.0. But what are my units? Feet. So this barrel here is 4 feet tall with a radius of 1.5, giving us that volume to 28.27. So it's a little working backwards type of problem. There on number 7. Anybody get that? 4 feet, number 7? One person? All right. What questions can I answer about that one? Any confusion on what we did, how we set it up? Or is it one of those things where it makes sense now that you see it? Or does nobody care? That's fine too.